Okay. Hi, good morning, everyone. This presentation is the result uh, from what I got of the crops dataset. Here's the dataset I got from Yan. From the right side, the FID is we can see that we have like 0.6 million of the point of the crops, and on the left data side, the VI set is the same as the FID. So what I do is I combine these two data sets so I can have the so I can know what which row is what crops like wheat. Since this data set only contains 4 crops, and there are 276 NDVI values from April 1st to December 31st. Once I combine this data set, I have like 7,818 points of data. So this is the data I'm gonna use. The first column is the crop type, and the other 276 columns are the daily NDVI values. For this time, I have wheat 2,935 and other 3 crops. Only 693 chickpea for this time. So I compared 2 data sets. The previous data set I only have like 651 samples, and this time I have 7,816 samples. So for each time I choose 70% as my training data set and 30% as my validation data set for each time. For previous one, I have 5 crops. For this time, only 4 crops: barley, canola, chickpeas, and wheat. I use the same algorithm as previous one, which is it's not a neural network. For first one, I have 1 year daily NDVI values, 365 input, and only do 1 linear combination of this value, and the output is the crop types. For first type, I use the same algorithm, but this time the accuracy is very low. It's about 40%. I'm not sure why this time I got this low accuracy. Maybe because the columns of the NDVI values I have, as you can see, the loss is never converge. It's just a jump all the way. So I tried other 2 machine learning approach. Like the first one is neural network. There are 2 types of neural network. The left one is non-deep feed-forward neural network, only 1 hidden layers. Another one is deep neural network with multiple hidden layers. So I try both. For first one, for both, the input always is 276 daily NDVI values, and I try different type of hidden layers, the number of hidden layers, the number of neurons, and the output is always 4 dimension because we only have 4 crop types this time. So the point is, I tried the previous model first, but yeah, it doesn't show me a good result. Then I tried things. I have another project is a case study learning about the neural network. So I tried this one. There are two types of neural network I used. And for the activity function, as Fred suggests, I use softmax as my final output layer activation function. For hidden layers, there are three activation functions I use: ReLU, sigmod, and linear function. The next slide is the results I have. For the first two, top left, I use only it's a non-deep neural network, only one hidden layer and one input layer, one output layer. For the number 8, layer 8 means the number of neurons. Linear means the activation function I used. So the last layer, I always use the softmax as my output activation functions. So the results shows linear function is not good for the because linear function, the gradient of linear function is always the same. So and the results, the test accuracy is only 57%. And then I try to have more layers and more runs. As we can see the bottom right, with 500 runs, 4 layers with different neurons and ReLU activation functions, and the test accuracy is about 95%. Here's a, I mean, there's another example from the results here. I just compare this last two results here, and another way I use to train this data set is called decision tree. It's another machine learning algorithm to do the classification, and also for the same data set. For this time, I also choose 70% as training data set and 30% as test data set. But this time, the label for the validation label is only one dimension because the decision tree will give me show me is this body or this weight. The whole decision tree is pretty large because we have so many columns. So I just cut a small piece of the whole tree.
Yeah.
X is my my data, and the square, the number in the square is a row, like X, the last one, X 58 is the rows.
Okay.
And
so you look at each day of the year.
Yeah.
From day 31 or whatever to day 276.
The decision tree also provide me a good results. It's like 89%. But for each individual, the precision is not much higher than neural network.
Yeah.
So these are the results from the decision tree I used.
Okay.
Epochs. The problem is that this is not converging. So that means I'm assuming that the bank is using out-the-box optimization from whatever package he's using. And they have so hyperparameters. The most important one here is the learning rate.
Yeah.
And it seems to me that the learning rate is either too high or
learning rate is too large, maybe.
Yeah, so I mean, it doesn't matter how many iterations you have. You can have 200,000 into it. You're not getting it.
Okay.
Right? Yeah.
It's not. It's not making any progress.
Converging.
The very first model is a convex problem, so that's the easiest one. You should be able to get it to converge. There's one solution. You should be able to get it. Whereas the neural net ones, you know, it's more involved. You have to make sure initialization is correct, other stuff. This first one, it's the one that, in my opinion, I think this is going to...
Bang, you have to just make, give some more information about how you select your training points and your testing points.
Yeah. And
it's all randomly selected, or you just go to, you started one field and then
selected as before.
Okay, you just have to make that clear.
Now we also have to make clear the difference between field ID and sample ID within field, because they're not the same thing. And when you build a model, as I understood it, it was made from a large number of fields, but Jan, have you got any idea of how many fields are in the 7,000?
Not many.
50 or 500 or?
There should have a columns showing the field names, not this field ID, but
this is new data. Yep.
Yeah, this in the data set.
Well, I guess my point is simply that we have to think about that type of structure when we're doing it. I mean, I know when we use a satellite that we can potentially sample multiple samples per field. That's great. But how we use that data and how we use it in a model becomes a really important question.
So, Great.
Okay. Good luck, Debang. Let me know if you got any questions about any of the technical stuff that you think I might be able to answer.
Thank you.
All right.
Thanks, Debang. Thanks, Jan. Thanks, Fred.
Thank you.
Is there anything we need